The space news this week in my inbox contains some very depressing and dire circumstances for NASA. However, I'm going to put on my ostrich feathers and report on all the positives I can find. Did you ever hang out in graveyards when you were young? My dad used to travel through a cemetery in the wee hours of the morning after working a graveyard, pun intended, late shift at the hospital. He was surprised by voices more than once coming from behind tombstones. Apparently in those days it was a great place to nap after the bars closed. The news today is that some of us all might have actually gone swimming in a graveyard. By analyzing samples from the deep sea, researchers have found a unique variety of radioactive plutonium that appears to be debris from a rare breed of cosmic explosion called a kilonova, which likely detonated near Earth some 10 million years ago. In fact, the ocean is actually a supernova graveyard. Something to think about during your next dip. So what is a kilonova? Kilonovas occur when binary neutron stars spiral closer and closer to each other until they finally collide and release tons of heavy elements into space. A kilonova is 1,000 times brighter than a nova, thus the kilo, but from 1/10 to 1/100th less bright than a supernova. We live in a supernova graveyard. Brian Fields, an astronomer at the University of Illinois' Urbana-Champaign, said in a March 17th presentation at the 2025 American Physical Society Global Physics Summit, supernovas make tiny specks of rocks that can literally rain upon the Earth. This next image is a chart of the HESS Galactic Plane Survey. In a paper from 2018, the Galactic Survey identified 31 sources as pulsar wind nebulae, PWNe, supernova remnants, SNRS, composite SNRS, or gamma-ray binaries. Among the 47 sources not yet identified, most of them, 36, have possible associations with catalogued objects. Notably, pulsar wind nebulae and energetic pulsars that could power VHE PWNe, which VHE is very high wind. But proving this kilonova's explosion's existence will require more evidence, and that researchers think that they know where to find it, on the surface of the moon. Which makes sense since it could be hit first by the fallout of any type of nova. Brian Fields states that the tiny rocks that accumulate in the depths of the ocean will also hang on to the moon. Quote, Fields has theorized about this cosmic rebel since the 1990s, but it wasn't until 2004 that researchers started sifting out supernova remnants from ocean samples. They found traces of a radioactive version of iron that doesn't occur naturally on Earth and can only be explained by a nearby supernova sometime in Earth's recent history. In the following years, about a dozen more samples from both the ocean and the moon painted a more detailed picture of this explosive history. Fields and his colleagues' refined theories pointed to two separate supernova events that occurred 3 million and 8 million years ago. This is direct observational evidence that supernovas are radioactive factories. Here is a recent supernova explosion from the James Webb Space Telescope. It's not a stretch for the imagination to believe that since a supernova explosion releases an incomprehensible amount of energy, with a peak luminosity of around 10 to the 43rd power ergs, or approximately 10 to the power of 38 watts, that radioactive fragments would easily find their way to Earth. Another way to think about it is a supernova releases 300 billion times luminosity more than the Sun. In October 2024, the James Webb Space Telescope released this photo of a supernova nicknamed Hope, a great name in my opinion. The plot thickened for Brian Fields' cosmic rebel theories in 2021, when researchers discovered an even rarer substance sprinkled in with those same samples, a radioactive isotope of plutonium. This finding required an origin story even more unusual than the violent star deaths that birthed supernovas. So it was kilonovas. Kilonovas are also factories for some of our planet's rarest elements like gold and platinum, and astronomers have long tried to unravel the mechanics of this class of explosion. Our supernova graveyard oceans have many mysteries and also hold many answers. One never knows what this planet will tell us about the space around and far beyond it. Surprises are everywhere, including this amazing photo. An octopus hitched a ride on the fastest known shark, a Shortfin Mako. This shark can reach speeds of 74 kilometers per hour, which doesn't compete with the speeds of the Shanghai maglev train, which is 431 kilometers per hour, but I bet either one is quite the ride. I'll take the train though, and keep looking for the little bits of surprise magic found close at hand or light years away.